Good day, everyone! Welcome to Quarter 3, Week 1 of Physical Science. I am your teacher, Lorraine C. Rivera of Umangan National High School. Do you have your self-learning module on hand? Be ready, because we will talk about the formation of heavy elements. But before we start, let's see the learning competency and specific learning outcomes. For learning competency, you must be able to give evidence for and describe the formation of heavier elements during star formation and evolution. For learning objectives, you should be able to 1. Explain stellar nucleosynthesis. 2. Describe the different stages of life cycle of stars. 3. Cite the different heavy elements formed in each stage of star cycle. And 4. Describe how heavier elements formed during stellar nucleosynthesis and evolution. The genesis of our universe led to the formation of galaxies, solar system, and other celestial objects. Do you still remember the different theories in the origin of the universe? I will give you 10 seconds and let's see if you still remember these theories. Correct! These are the divine creation theory, the steady state theory, oscillating theory, and the Big Bang theory, which aim to prove that either is the origin of the universe. But from all those theories, one is currently accepted, and that is the Big Bang theory. Scientists believe that the formation of the universe began through a rapid expansion of primordial atom. And when did it happen? Correct! It happened 13.8 billion years ago. Big Bang nucleosynthesis occurred where the lightest elements, hydrogen and helium, were formed. These elements are formed from the fusion of nucleons, proton and neutron. Well, stars are profoundly used in studying the universe, so many scientists believe that stars produce raw materials that make life possible. Do you know that the process by which heavier elements are created within stars by combining the protons and neutrons together from the nuclei of lighter elements is called stellar nucleosynthesis? But to fully understand this process, it is important to study the life cycle of a star. All stars start from a large cloud of gas and dust called nebula. Over time, the hydrogen gas in the nebula is pulled together by gravity and it begins to spin. As the gas spins faster and faster, it heats up and becomes a protostar. The collapsing gas and dust burn hotter, eventually reaching temperature sufficient to fuse hydrogen into helium. The star turns on and becomes a main sequence star. When a main sequence star begins to run out of hydrogen fuel in its core, leading to its contraction and expansion, the helium fuses into carbon and the star becomes a red giant. After a low or medium mass star has become a red giant, the helium in the core runs out, and when the helium ignites, the outer parts grow bigger and drift into space, forming a cloud of gas called a planetary nebula. The remnant blue-white hot core of the planetary nebula is called the white dwarf star. Theoretically, a white dwarf that has cooled sufficiently that it can no longer emit significant heat or light is called the black dwarf. A more massive star evolves, cools, and expands faster than low-mass star will turn into red supergiant. Carbon fusion still occurs and oxygen is formed. When a red supergiant starts to burn carbon, this continues with fusion of heavier elements until iron, which then inevitably collapses to produce a supernova. This explosion releases large amount of energy and disperses elements into space. After the supernova, some of the materials from the star are left behind. This material may form a neutron star. On the other hand, the most massive stars become black holes when they die, leaving a large amount of mass. Eventually, the gravity becomes so strong that nothing can escape, not even light. After learning the stages in life cycle of the star, let's have our activity number 1. For this activity, you will be given 5 seconds to answer each item. Name the stage of life cycle of a star that is being shown. Number 1. It is a large interstellar cloud of gas and dust. Yes, you are right. It is called the nebula. Number 2. It is the early stage of a star resulting from heated up hydrogen gas. You got it right. It is called protostar. Number 3. It is when the collapsing gas and dust burn hotter, sufficient to fuse hydrogen into helium. Good job! The answer is the main sequence star. Number 4. It is a giant star of low or average mass star beginning to run out of hydrogen fuel and helium fuse into carbon. Correct! It is called the red giant star. 5. A dying low or average mass star where helium runs out, forming a cloud of gas and dust. Excellent! It is called the Planetary Nebula. The remnant blue-white hot core of the Planetary Nebula. Do you now have the answer? Great! It is called the white dwarf star. 7. A giant star of high mass star where carbon fusion still occurs and oxygen is formed. Correct! It is called the red supergiant star. A late stage of a dying high massive star, which explosion releases large amount of energy and disperses elements into space. You are right. It is the supernova. 9. It is a remnant of high massive star that died in a fiery explosion known as a supernova. Great! It is called the Neutron Star. Number 10. It is the remnant of most massive star where gravity is so strong that nothing can escape, even light. Good job! It is called the black hole. Marvelous! You can now describe the stages of life cycle of a star. But how do stars are formed into different stages? This is because of nuclear fusion happens in stellar nucleosynthesis. For most of their lives, stars undergo this process. So here are the processes of nuclear fusion reaction. In proton-proton chain reaction, two hydrogen nuclei fuse together forming deuterium, emitting positron and neutrino. Deuterium then rapidly captures proton and forms helium-3 while releasing gamma ray. When two helium-3 nucleus combine, it will form helium-4 and two hydrogen nuclei. While case is different in massive star or star 8 times larger than solar mass, they undergo the carbon-nitrogen-oxygen cycle or the CNO cycle. In CNO cycle, hydrogen fuses into helium using carbon-12 as catalyst. carbon-12 nucleus captures a proton while releasing gamma ray, producing nitrogen-13. The unstable nitrogen-13 nucleus undergo beta decay to produce carbon-13. Carbon-13 catch a proton and becomes nitrogen-14, emitting gamma ray. Nitrogen-14 captures another proton and becomes oxygen-15, releasing gamma ray. Oxygen-15 becomes nitrogen-15 via beta decay. Nitrogen-15 then captures a proton and undergo alpha decay, which is a type of radioactive decay, emitting alpha particle helium-4 and transforms into carbon-12. Another neutron capture process is called the triple alpha process, which happens in red giant star once they leave the stage of a main sequence star. It begins when two helium-4 nuclei fuse to form an unstable beryllium-8 nucleus. If beryllium-8 collides with another helium-4 nucleus before it breaks apart, it will form a carbon-12 nucleus. Then the energy released is carried off both by motion of the carbon-12 nucleus and the gamma ray. After enough carbon has accumulated, alpha ladder process takes place. In alpha ladder process, when a star accumulates more mass and continues to grow into red supergiant, alpha particle fusion happens at its core and creates more heavier elements until iron. Though a star may explode as it reaches the point where iron is forming inside its core, the cycle ends with nickel-56. Nickel-56 having the highest binding energy, then decays into cobalt-56, then to iron-56. As the energy at the core of the star decreases, nuclear fusion cannot produce elements higher than iron, so different pathways needed for heavier elements to be formed. In neutron capture process, a neutron is added to a seed nucleus to form heavier elements. Neutron capture can be slow or rapid. In S process or slow process, it happens when there is a slow rate of capturing neutron while there is a faster rate of radioactive decay, hence increasing the proton. The elements heavier than iron, which origins in larger stars, are typically those produced by the S process, which is characterized by slow neutron diffusion and capture over long periods in such stars. The R process creates neutron-rich heavy isotopes, which decay after the event to the first stable isotope, thereby creating the neutron-rich stable isotope of all heavy elements, and that is called the supernova nucleosynthesis. This neutron capture process occurs in high neutron density with high temperature conditions. Aside from gases, hydrogen and helium in space, other evidence of star formation is the energy emitted during nuclear reaction. It is also the energy emitted by different forms of radiation such as ultraviolet radiation, infrared, X-ray, radio waves, and microwave. Now that we are done discussing stellar nucleosynthesis, let's have our second activity. In this activity, you will be given 10 seconds to answer each question. Identify the nuclear fusion process being described. Number 1. This is a nuclear fusion reaction in which 4 hydrogen nuclei are involved to form helium-4. A. Alpha ladder process. Letter B. CNO cycle. Letter C. Neutron capture process. And letter D. Proton-proton chain reaction. Correct. The answer is letter D. Proton-proton chain reaction. 2. This is a nuclear fusion reaction which converts hydrogen into helium using carbon-12 as catalyst. A. Alpha ladder process. B. CNO cycle. C. Neutron capture process. And letter D. Proton-proton chain reaction. Good job! The answer is letter B, CNO cycle. 3. This is a type of nuclear reaction in which a target nucleus absorbs an uncharged particle to form heavy elements. A. Alpha ladder process. B. CNO cycle. C. Neutron capture process. D. Proton-proton chain reaction. Great! The answer is letter C, Neutron Capture Process. 4. This nuclear reaction happens when a star accumulates more mass and continues to grow into red supergiant. Helium-4 fusion happens at its core and creates more heavier elements until iron. A. Alpha ladder process. B. CNO cycle. C. Neutron capture process. D. Proton-proton chain reaction. Correct! The answer is letter A, alpha ladder process. 5. This process is faster rate of capturing neutron before it undergoes radioactive decay. A. Neutron capture process. B. R process. C. S process. D. Tri-alpha process. You are right. The answer is letter B, R process. That is awesome. You are now able to describe how heavier elements are formed during stellar nucleosynthesis and evolution. Did you have a good time in learning? That is good to hear. And now that you have learned how stars are formed and evolved from one stage to another, and its connection with heavy elements from carbon through iron. So for evaluation and your final task, write a story which relates the events of your life from past, present, and future to the life cycle of a star. Use also those elements which could symbolize something or anything in your story. Here is the rubrics for evaluation. For overall effort, if work shows time, effort, and neatness that enhances the overall written output, it will get 5 points. If the work shows time and effort put into it, you will get 3 points. And if it lacks effort and cleanliness, it will get 1 point. For background context, you will get 5 points if your output contains background context and shows how world events have significantly affected your life. You will get 3 points if the project contains discussion of world events but it is unclear how they have affected your life. And you will get 1 point if there is no background or contextual information that is included. In grammar and spelling, if you didn't commit any error, definitely you will get 5 points. But if you commit 1 to 3 grammar mistakes and spelling, you will get 3 points. But if you commit more than 4 mistakes in grammar and spelling, don't worry, you will still get 1 point. Lastly, the content. If you include information about your birth, friends, families, and hobbies, and is able to tie your story to the topic given, you will definitely get 5 points. But if you include very few details, and your output is somewhat tied up with the topic, you will get 3 points. if the information included is not related to the task or no attempt was made, you will get 1 point. I hope you learned a lot from this lesson. Once again, I am your teacher, Lorraine C. Rivera of Umangan National High School, saying study hard and stay safe. See you next time. Bye!